So guys, welcome to our channel once again. In today's video, we have here these 10 questions to answer on the topic simple harmonic motion. So in short, to stay till the end of this video, let's go ahead and start with the first question here. It says, a loaded spring performs simple harmonic motion with an amplitude of 5 cm if the maximum acceleration of the load is 20 cm per second squared. Calculate the angular frequency of the motion. Alright, so guys, in order for us to calculate the angular frequency of the motion here, we are going to have that as the acceleration here. But then we have to recall that the angular velocity, which is omega, will be the acceleration over the amplitude or radius of the path. So in that case, we'll have that omega squared is equal to a over r, since a is equal to omega squared r. So since we are calculating for the omega, which is the angular velocity, that will be a, which is 20 cm per second squared, over the r, which is 5 cm, and guys, 20 over 5 is 4, so omega squared is equal to 4. So in order to find omega, we'll square root this 4, and that's actually the square root of 4 is 2, and that's 2 radians per second. So that's it for this question. Option C becomes the answer to this question, 2 radians per second. So that's the angular velocity here. Let's go ahead and consider the next question. So guys, the next question we have here is question number 2. It says, an object is said to undergo oscillatory motion when it moves A in an erratic manner, B to and fro about a fixed point, C in a circular path, D along a continuous path from the starting point. So guys, the answer to this question is option B here. An object is said to undergo oscillatory motion when it moves to and fro about a fixed point. And that's it for this question. Let's go ahead and consider the next question, guys. So the next question here is question number 3. It says, which of the following statements is correct about resonance? Resonance occurs when a body A is forced to vibrate at its own natural frequency by another vibrating at the same frequency. B vibrates at a frequency of the body causing the vibration. C vibrates with its natural frequency. D vibrates with an irregular frequency. So guys, the answer to this question is option A here. Resonance is caused when a body is forced to vibrate at its own natural frequency by another body vibrating at the same frequency. So let's go ahead and consider the next question, guys. So the next question we have here is question number 4. It says, a pendulum bulb executing simple harmonic motion has 2 cm and 12 Hz as amplitude and frequency respectively. Calculate the period of the motion. So guys, for this, what we'll just simply do is that the period t is equal to 1 over the frequency, and the frequency here is 12 Hz. So 1 over 12 is 0.08 thereabouts, and that's option A here. So guys, option A is the answer to this question. Let's go ahead and consider the next question, guys. So the next question we have here is question number 5. It says, the period of oscillation of a particle executing simple harmonic motion is 4 seconds if the amplitude of the oscillation is 3 meters. Calculate the maximum speed of the particle. So guys, in order to calculate for the maximum speed of the particle, let's take note that actually V is equal to omega r. So if V is equal to omega r, then let's calculate for omega here. Omega, which is the angular velocity, is actually the displacement over the period here. So the displacement on one complete cycle is actually 2 pi. So when you have 2 pi over the period given to us here for one complete oscillation is 4 pi. So 2 pi over 4 pi is actually 1 over 2. That's 0.5. So when we multiply this by the amplitude, which is R, we are going to have 0.5 times 3, and that's 1.5. So option C is the answer to this question. Let's go ahead and consider the next question, guys. So guys, the next question here, question number 6, says, which of the following statements about simple harmonic motion is correct? The A, linear acceleration is directed to any variable point. B, linear acceleration varies inversely with displacement. C, total mechanical energy is always conserved. D, period of oscillation varies nearly as acceleration due to gravity. So guys, the answer to this question here is option C. The total mechanical energy is always conserved. So let's go ahead and consider the next question, guys. So the next question here is question number 7. It says, the amplitude of the motion of a body performing simple harmonic motion decreases with time because A, energy is supplied by some external agencies. B, the period of oscillation varies over time. C, frictional forces dissipate the energy with time. And D, the frequency of oscillation varies with time. So guys, the answer to this question is option C here. Frictional forces dissipate the energy with time. So let's go ahead and consider the next question, guys. So we have here question number 8. It says, the period of a simple pendulum X is 5 seconds. What is the period of a simple pendulum Y which makes 50 vibration? Actually, guys, the question here is the period of a simple pendulum X which makes 20 oscillations is 5 seconds. What is the period of a simple pendulum Y which makes 50 vibrations? Alright, so guys, we have to understand that the period here is actually number of vibration over the time. So in that case, the time also is equal to the number of vibrations over the period. So guys, if the time is actually number of vibrations over the period, then we are going to have that the number of vibrations over the period for X is equal to the number of vibrations over the period for Y. So in that case, the number of vibrations for the X is actually 20, then over the period for X, which is 5, and this will be equal to the number of vibrations for Y, which is 50, over the period for Y, which is not known. So let's call that T sub Y. So in that case, if we want to find T sub Y, that will be equal to 50 vibrations times 5 seconds over 20 vibrations. So guys, if we go ahead to calculate this, that will be 50 times 5 over 20 is equal to 12.5 seconds. And that's option A here. So that's it for this question. Let's go ahead and consider the next question, guys. So guys, the next question here is question number 9. It says, the frequency of a swinging pendulum is the A, angle the bulb swings through in 1 second. B, distance the bulb covers in 1 second. C, number of amplitudes the bulb makes in 1 second. D, number of complete oscillation the pendulum makes in 1 second. So guys, the answer to this question is option D here. The number of complete oscillations the pendulum makes in 1 second. So let's go ahead and consider the next and last question, guys. So the next question we have here, question number 10, it says, a simple harmonic oscillator has a period of 0.02 seconds and amplitude of 2.5 meters. Calculate the speed in meter per second at the end of the oscillation. So guys, for this here, we want to calculate the speed at the end of the oscillation. Let's recall that V is equal to omega R. So in order to calculate the linear speed here, we have to find the angular speed and multiply it by the amplitude, which is the radius of the path here. So guys, for this, we are going to have that omega is actually 2 pi f. So if we want to find the angular speed, which is omega, we're going to use this formula 2 pi f, and 2 times pi times the frequency here. Actually, the frequency is 1 over 0.02. Since the period is 0.02, that means the frequency is 1 over the period. That's 1 over 0.02, which is about 50 hertz. So that's 2 pi times 50 hertz. So in that case, the omega, which is the angular velocity or angular speed, is actually 100 pi. So in that case, if we want to calculate for the linear speed, we are going to use 100 pi times 0.25. So we'll multiply this 100 pi by 0.25. We are going to have 25 pi, and that's option B here. So guys, the speed of this simple harmonic oscillator is 25 pi, and that's option B. So this is where we'll end this video for today, guys. If you enjoyed this lesson, please give it a thumbs up. Don't forget to subscribe to this channel if you're not yet a subscriber. Also, if you have any specific question regarding this video, you can drop your question in the comment section below, and we'll be sure to give you a response. So finally, guys, I want to encourage you to join our YouTube channel community. So you can join this channel community by hitting the join button below, and we'll see you right there. Thank you once again for watching this video. See you on the next one.